Okay, hello everybody. This is me, Andre, again, and what I'm doing today is another study sesh. Um, our topic will be about classical mechanics. Okay, so let's first start off with a little bit of a basic understanding of physics. Though my understanding of physics is a little bit limited, but you know, you learn and try stuff. It's just first try to get an understanding of what the basics are in physics. So we have F equals ma. I'm sure a lot of you already know what this means. Force times the mass of acceleration. Of force equals mass times acceleration. This is basically where kinematics happen. It's concerned with how motion works, I believe. How motion works, and this part is concerned with dynamics. What causes that motion? Okay, so let's go to our trusty textbook uh, and see what we can learn. Okay, we just uh, copy a textbook here. We have Here we go. This textbook is Introduction to Classical Mechanics by David Morin. I basically found this book from the MIT Open Courseware site, so you guys can check that out as well. So I'm just giving the credits here. Um, let's start let's start with the basics first, like a conceptual background. Okay, it says here. Um, okay, let's start with chapter 1, statics. Number 1, balancing forces. A static situation is one where all the objects are motionless. You guys can read it aloud. You guys can just read it quietly inside your head. But I'm going to read it as well. And I'll try to explain how I interpreted the text later on as we move along. What is torque? Okay, so how I understand this, so the book basically just says that there are these four balancing forces that are inherently present in everything. So I'm just going to try to explain what I learned in the best way that I can. The first, the first force I believe Mr. David Morin says is that the okay, tension. The first is tension. So tension is basically let's say you have a rope, okay? Let's say you have a rope, okay? Let's say you have a jumping rope. And whenever you pull this from side to side, okay, from side to side, let's say this is you. Whenever you pull this from side to side, the rope, the jumping rope, is actually exerting a force. Okay, there's actually a force exerted from the jumping rope. Okay, but at its endpoints right here. What I mean by endpoints is where the handles are of the jump rope. These, I believe, do not experience any force from from these points. Instead, the force, I believe, is from the I believe the force could be from the person themselves that is exerted upon these two endpoints of the jumping rope. From my own understanding, from my own understanding of the text, okay? So that is what we call the tension force. Now we have what is called the normal force. And how I understand it is, I'm basically just using visual analogies on how I understand this in order for us to really, really get, really get the essence of what these things entail. So we're going to go to the normal force now, and the normal force basically just says that, okay, let's say you're in a bouncy castle. You're in a bouncy castle, okay? Let's just say this is the bouncy castle. Inside, you're inside a bouncy castle. Of course, the floor, okay? The floor, let's just say that the bouncy castle is half inflated, but also not inflated, okay? So half and half. And the surface is basically just the floor, okay? Just the floor of the bouncy castle. So I believe, okay, if you put yourself in that bouncy castle and you stand on the floor of the bouncy castle, then the floor will be squashed because the force, okay, the normal force of the bouncy castle is basically exceeded by the force that you, okay, put onto it. And only then when you remove yourself, only then when you remove yourself, okay, only then when you remove yourself from the bouncy castle will the ground um, basically go back to normal, okay? Because the force of the bouncy castle, the floor of the bouncy castle, is equal to the amount of force that is on the top of the bouncy castle. So they're basically equal. From my own understanding, okay? Now let's go to the third type of force, type of balancing force that Mr. David Morin talks about, which is basically just friction. Okay? And how I believe this works is that normal force and friction are related to each other. As I said with the bouncy castle analogy earlier, the amount of force you put onto the surface directly affects that surface, and the surface has a force that is and the force that the surface has is actively exerting itself upon the object as well. And friction is basically just building upon that. Okay, it's basically just building upon that. And we will have two primary types of friction. I believe the first one is kinematic friction. I may be wrong on this, but I'll just recheck earlier, and we'll try to correct our mistakes earlier. Later on. I'll just try to correct my mistakes later as we move along in the video. So now we have static friction. He mentioned two types of friction. Okay. So how I understand kinematic friction is, okay, it basically just deals with the friction that is on the surface, that that also deals with movement. Okay, so let's try to get the example from earlier on the book. Okay. Never mind. I don't really understand kinematic friction that much, but we'll just try to get a clarification later on. But static friction, yeah, I think the only thing I understand from these two is that one is related to moving objects, and one is not. Okay, so static and kinematic friction. The fourth balancing force will be gravity. Okay. Okay. So that's the extent of what I learned from so far. Okay, so let's continue on. So I think I'm going to have to pause this study session for now, but I will get back to this in a later date. So we'll just leave this as it is. I know it's page 16, but just for us to expand a little bit on this, I'm going to add more of what I learned about physics. Try to explain it just so that the video isn't just all about this. Okay, so we're gonna talk about you know, these is coordinate systems that they use for movement vectors. Okay, so let's just say that you're running. Say that you're running. Okay, this basically just a point of origin, and there are these lines right here resemble time. Okay, time, 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 and distance. It basically just measures, this coordinate system basically just measures um, what acceleration, what acceleration what did you have at certain points of these times, and I think this will be it. You know. Now I have to admit that I don't know a lot about physics. Okay. This is the first time I'm actively learning it, so hopefully in later videos and study sessions, I'll get a little bit more in depth and learn more as I go and study. Okay. So thank you for listening and thank you for watching this video. So if you liked it, if you learned just a little bit, okay, please subscribe, and I would really appreciate that. You know. Thank you for watching.